All right, good afternoon. Today we will be continuing our series on improving the model for the NFL's Big Data Bowl for 2025. Shared out a link here that has the overview for what we're looking for in the competition. The idea here is that there are 3 tracks. Since we are not undergraduate, we are not eligible to enter into that track. The second track is the metric track. So you want to use the pre-snap data to try and create some type of post-snap outcome. It's pretty open-ended. What I've started with just at a very basic level is just predicting run versus pass. And we have that here at the base of our model. So we started with a logistic regression for that, and then we added a random forest model and a support vector machine. The idea was starting with a logistic regression is it's like the most simple to use out of the box for a given for an outcome that is either binary or somewhere between 0 and 1. So in this case, because we are predicting pass versus run, it's really easy to use logistic model because it's going to be either essentially 0 or 1, run or pass. So that's why we started out there, and then we added some more complicated model. But what we've seen so far is that actually that logistic regression is more accurate than the other models. For the last session, we had shifted to using all of the pass attempts. We were no longer only counting the pass completions. We did get a little bit of a drop in the accuracy, but not that much. It was less than half a percentage point on the logistic regression model. But for the random forests and the support vector machines, we saw a more significant drop there. So scrolling through, I'll just kind of quickly cover some of the other things that we had looked at here. So in our first session, we wanted to get an idea of the shape and completeness of the data. So they provided a really clean data set here. You'll notice that some of these do not have values filled in, but it makes sense once you look at the data here. For example, this yard line side is when the ball is at the middle of the field. It's neither one team or the other, and that's what that field here represents. Then you'll see things like the offensive formation and receiver alignment. These are mostly the punt and kick plays, as there's no formation or alignment assigned to those. Similarly here, the pass result and length. These are the plays where there are a rushing attempt, or in this case, a rushing attempt or incompletion, because there's no length on that pass. And then from there, I wanted to go in to get a better idea of just kind of what the averages are, what are your expectation on a given play. And quickly notice something here when I'm looking at the mean of the rush yards. And the reason for that is this player play has all 22 players that are on a field for a given play. But when that happens, only one person is actually getting the rushing yards. So that significantly decreases the mean here. And then once we found the field to figure out who the runner actually was, and we use that as a filter, now we have a more realistic explanation of what the rushing yards is. So here, you'll see on average on a rushing play, they gained about 4.5 yards. A very similar thing happened with receiving as well. We had looked at both of these simultaneously. And so we just looked at who has the pass reception to get an idea of who had the receiving yards here. So on a given pass play, when it's received, you get about 11 yards per reception. And then we did some grouping and filtering to get an idea of who are the top 5 offenses for rushing. We saw Chicago, Las Vegas, Seattle, Jacksonville, Baltimore. And then the opposite of that, so changing from sending false to true, you see the bottom 5 offenses in terms of rushing. And then here we are for the top offenses as far as passing goes on those completions. So on average, this meant that Miami got the most yards per reception. We're just below that 13-yard mark, but in general, you saw that there was a 10 yard or 11 yards per average reception here. So you can see there's quite a bit of variance between the teams who perform very well versus others. And just so you have an idea, they do provide us what the different fields are in the data that they've provided to us. So each of these files here, games, player play, players play, they tell us exactly what those fields are supposed to be. And we can see that with the link there to the data set. So then once we looked at the data, as we kind of expected, there are, those 1 or 2 big plays that happen throughout the season. And so those are the outliers in terms of the average rush numbers. So we wanted to make sure that we go through and we filtered those out. So you can see very high average on those kind of singular rush attempts. So we just had a minimum of 10. The number here is arbitrary. You can put whatever number that you actually want in terms of the number of rushes, but I feel like 10 is a good number. You can see that there are still some of the very close to that limit in the data here, but 10 is good enough to get rid of the majority of these outliers in terms of getting an idea of like who the best player was per or on an average rush attempt, given that they've rushed 10 times. Then working into the data set, I included a flag field. So is there motion on a given play? So we have that here, and then trying to get and begin grouping the data so that way we can use it for a predictive model here. So I should go back to the beginning and start running some of these as we go through. So we have an idea. Okay, so that actually ran already. We don't need the null numbers. We can do this. It's just going to give you an idea of like who the rushers are. I do want to include this, although I don't know that I've incorporated this into the model, and we can get to that today where we're looking at the was there actually motion, and did that help help the model to determine whether it would be a run versus a pass play. So then this is the overall grouping here. So this is in a play motion data frame, but I don't see that here at all in the data set here. So this shouldn't entirely be shocking there, but we should include something like this in our data. So let's take this here and we'll move it down once we get to that section. So right here, this creates the larger data set that we had been doing here. Oh, this actually does include the play motion. Okay, perfect. So then we'll leave that there, including motion in the play. This grouping here tries to, or does determine who were the 11 offensive players on the field. So, did this actually help us to better understand who was on the field? I think there was just based on the title of the video of that stream, we spent basically an hour and a half to find out that knowing who was the player on a field on a given play does not actually help improve the model's performance on whether it was a run versus pass. Now, this may matter more once we get to predicting something like what were the route combinations that were run, if we want to get into that more complex model. But as far as just making the prediction of run versus pass, it didn't particularly help. So this will take a little bit of time to run. And then this is focused solely on the offensive players. So we do another grouping here just to bring those back in. And then this view here will give you an idea of what it actually looks like on a given play. So for example, this play, no rushing yards were gained by Tom Brady, but then the offensive players here on that play will be all of the Tampa Bay players on the field for it. Then this is when we get down to building the actual model. You can see here, this is the fuller data set. Last time we worked on adding some visualizations to help better get an idea of the data here. So this stacked bar chart here gives you an idea of the formations of each team based on the percent that they had through the game. So this is 100%. Here, what you'll see is that a lot of teams used a heavy amount of shotgun with few exceptions. So teams like Atlanta and Baltimore are a little more balanced here, where they have two major formations that they run out, and then like two lesser used formations provide good balance to their offense in the course of the game. And then you'll see other teams here where they barely even use some of the formations to help out their offense in terms of being more balanced. This is the one that we'll come back to and improve. This is just displaying the team's offensive performance based on the average pass yards versus the average rush yards. The idea here is that the better offense, you will want to be more up and to the right here, rather than being kind of down and to the left. So if you are in this left quadrant, then you have below average pass and above average. Sorry, you have above average pass and below average rushing. And then if you're in this upright corner, you are above average on both. And then if you're in this lower right corner, you are above average on rushing, but a little bit below average in terms of passing. And you can see, if we were to draw in dotted lines here, basically at those averages, so think of the 11-yard mark and then about this 4.5 mark, you can see a lot of teams actually were grouping into this upper right-hand quadrant, which is where you want to be. But then these ones here, for example, were offenses that were not as performative in terms of getting the outcome that they would want on a play. The reason why we'll come back to this is I've gotten the team icons here. We'll work to incorporate those into the graphic here. The only one who I am missing is Washington's offense, or Washington's logo here for their offense, because they didn't have it in the data set that I had found. So I'll have to find an image that we can use for that. And then continuing down to where we actually start to begin to build out that model, you'll see we need to create a flag field that indicates whether it is a rush versus a pass play. So we have that here. If it's a 1, then it was a running play, and then we just determine that by where they're rushing yards. Everything else is a pass play. Then this was the very basic model. There were basically 4 fields, 3 if you take away what we were trying to predict in terms of our run. This was purely knowing the formation that the offense is in, what team it is, and what were their receivers on a play. When we looked at this, you can actually see that it's actually a very predictive model, knowing that alone. You need 70.5% accuracy for knowing just those 3 pieces of information, and you can see that clearly before the snap. You'll have an idea. You'll know who you're playing against, right? Then you can see kind of how their formation lines up, and then what is their receivers in terms of how they display, or how they're laid out on the field. Then we worked to create a more expanded version of the model. We added the quarter, downs, yard to go, this score differential, which uses the home score and the visitor score. And then the absolute yard line is how many yards they have to go to score a touchdown. The outcome of this actually improves the model. And this basically provides the context of the game situation here. So, quarter, is it the first quarter? Is it the fourth quarter? How much time is actually left? All those go into what's available to offenses. And so they're all important to the information here. The yards to go, there's a bucketed and a unbucketed version. Depending on the model, that actually gives you better performance. So you'll hear this frequently when you're listening to the game in terms of what the commentators are talking about. You'll hear them say like 3rd and long. What that typically means is that there is more than 7 yards to go to get a first down. You'll hear like 3rd and short, or okay, they've got 2 yards to get the first down. Or usually when they're middle range, they'll say exactly what that yard range is. So they'll say, 3rd and 5, 3rd and 6, and that gives you an idea of those different buckets. So I tried a version with and without the buckets, whether you use the yard by themselves or the bucket themselves. Same thing for the absolute yard line number. The logic that I use here is this short group is basically once you're in the red zone, which means you have 20 yards to go, 20 yards or less to go to get a touchdown. So that's that short field here. Middle field is anything that's basically within your kicker's range. And then I made that cutoff 50 yards. It's kind of arbitrary on what you want to use for this number. And, if we're incorporating this based on each team, you would see fluctuations for those, right? So this distance bucket would probably get better if we had a way to incorporate what the individual kickers were for a given team. Then I made a game time remaining field here. instead of just the game clock, we need to add minutes back for each quarter that is remaining. So if we're in the fourth quarter, then it's just what the game clock is. But if we're in the third quarter, we need to add 15 minutes to that game clock. Second quarter, 30 minutes. First quarter, 45 minutes. And then I made another bucket here for just the time remaining. And these are the indicators for the final 2-minute warning and then the halftime 2-minute warning. So what you'll see here is that each team treats the game a little bit differently based on how much time is left. Sometimes what you'll have is the game is already in hand. So this final 2-minute warning will be the offense that has like a 2-score lead. They're just going to kneel the ball to run out the clock and end the game, and the other team's not going to be actively calling timeouts. So that's why when you look here at the value counts, you'll see that the final 2-minute warning actually has far less plays than what you have in that halftime 2-minute warning. The reason why is that the game situation is different, right? When you're coming up to halftime, if you're the offense, you want to quickly try and get into field goal range to get some points. And then if you're the other team, you want to try and hold them to prevent them from scoring and affecting the score outcomes going into the half. So then we took all these fields, put them together. We're using the score differential just as a number. We're using those buckets that we created, the yards, distance, and the time, and then using that motion flag here as well, and trying to make a model. What you see is our accuracy actually increases from that 70.5% up to the 74%. So quite a bit of increase in terms of adding a few fields. What we actually see here, and I won't run because this takes a little bit longer, is that adding the player information to this model actually caused us to decrease our accuracy slightly. So we went from 74.1% now down to the 73.9%. So in terms of predicting run versus pass, it's not adding anything to our model in terms of the performance here. And then this version here treats that yards to go and yard line number as numbers instead of treating them using those buckets. So when we added those, we got another lift in terms of the model performance. We got another about 0.3 percentage points in terms of the outcome. And then you can see using the player, it took long, and you actually get worse performance here. You're at 73.8% again. The last two here are the random forest model. This one is not using the players because that's the previous version that I run. We do want to come back and try and do a version here to see if that's actually a better performance or not. So if we add this here, random forest with players at a 74%, and then when this runs, we can do the comparison. Oops. We get an idea on the player data in those situations. So you can see here. Oops. There we go. So you can see here, it actually, that formatting does kind of suck. You can see we actually get about a whole percentage point lift in the random forest model by knowing who the players are, but then that logistic regression model, we see that decrease in information. So it'll take to finish up the support vector classifier running. So I'll use this point. If you have any questions, please feel free to drop them in the chat. We can discuss those while those are running. Okay, there you go. slow getting that information. There we go. Okay. So you can see here for the more complex models, it's actually better to know who the players are, whereas the more simplistic models, we actually saw a decrease by knowing who the players are on the field. So for today, we're going to go back and update this graphic here to display who the offensive teams are using the logos that I have on the field. And then I'll keep a line in here for the Washington Commanders to just put WAS above theirs, just because I don't have that information available to me, or that logo available to me. So let's go there. And Society is using Matplot, but I need to bring in this. The reason for this is that I'm bringing those images into the plot, and I need Matplotlib's image package here, and then adjust text will allow it to dynamically update the text, so that way there's no, or not, the images and stuff and logos don't overlap with one another. So then we have this, and I want to include the team logos. I'm going to use the dictionary, and each team now has to go into the dictionary and get their logos. So then that is logos slash. I saved all of them as PNGs, but now I need to go through and do this for each one. What else do we have here? And if you have any questions, whether it's about football or what we're doing here, you can feel free to ask them in the chat, and I'll check them out as I go through and add this in. We're going to have to do this for every single team. So it gets tedious, but it will dramatically improve the output of what you're seeing here in the graph. So Dallas. Denver. Detroit. Trying to keep them all in alphabetical order here. So I'm using the legend from the graphic. Suppose I can just easily use the list here. You do have to be careful here. It is case sensitive along the way. So it is important that I capitalize the Indianapolis, for example, the IND there. Same thing for Houston, all those, just to make sure that we are matching up with the actual file names. And then those match to what's in the table. So you'll see here, for example, we just got the KC. There's two LAs. So in my case, I actually called the Rams LAR. So I do need to be careful here. But then there's also LAC, which is the Chargers. So let's see, did they call them horns? Yeah, they just didn't know. Okay. So let's see, there's still an order. Yeah, SF is still SF. Almost there. Yeah, so the only team remaining is Washington, which, like I said, I don't have the image of. Just give me a moment here. So this one should go through and update the graphic. The only thing now is that I need to include some logic here to make sure I find the logo. If I don't, then I have to just put the team letters there. So I'm going to make some adjustments to what I have here as far as the graphic goes. this is very similar to, you'll see the line here below, but I need to get rid of that. And I'm going to work on creating some logic here for the teams that I need to include. So we go off the team yards dataset. And if you're using iter rows here, it gives you two lines. One is, or it gives you two things back. One is the index, or the row that you're currently on, and the row will be the actual value here. So team equals row. And this is the team abbreviation. Then you have, we need to know their rushing yards. And the Y is going to be their receiving yards. Now, if it's in the team logos, it's going to go through that dictionary. It's going to find that team's, whatever their abbreviation is, and then get their path to the flow file here. Then we're telling it on the graphic to then show the image here. And I'm going to make some adjustments to it. And then if we don't find that, we need to now add that same text here. I'm just going to use 8 as a small text. Make sure it's centered. Both horizontal axis and the vertical axis. And so essentially that goes through this line here. And I need to make adjustments. So this is a x.set_title. And it's all going to be the same things here. So replacing the PLT dot with each of these. Oops. In this case, I don't want to include the legend here. And then this is where we're going to use that adjust text to make sure that there's no overlap. And then show. So should come in here to read through and run. We're going to import those. And hopefully this gives us the output that we are expecting. I guess it would help if I spell it right. Okay, so go here. We want to install. Okay, now if that runs, it shouldn't be a problem. So give that a moment, and I'll use the time to check in the chat here if we've got any questions from folks. Okay, those images are far too big. Let's do 0.1 on each of these. That's part of the experimentation. You see the blobs don't exactly look great. By taking these down each by a tenth, we're making it almost 100 times smaller. And hopefully we get a better idea of what it's going to be looking like. So that's better. It looks like the Y's are a little too small. So we'll let it run again. This should get bigger. Yeah, it looks like all of them are a little too wide, but that is also probably the ratio that I have set for the X and Y limits on the graphic, because the X is only covering a range of 4 total, but the Y is covering. So there we go. Much better looking now that we see that there. So as I was saying, X really only covers 4 unit distance, whereas the Y covers about 8. So by doubling the Y values compared to the X, now they look more in their actual aspect ratio. So another thing I should do here is to make lines that go through for the average rush and the average pass yards. And then that would give you an idea of like what the quadrants actually look like. But this gives you also a good idea on how teams were doing compared to the average on offense. So you can see here, Chicago is kind of more up and to the right in terms of their performance. So they have above average passing and rushing. And then you can see here, for example, Atlanta and Miami, compared to Chicago, a little bit less performance in terms of the rush, but better performance in terms of pass. And so, you'll see probably the good offenses will usually be kind of along a horizontal or a diagonal line going across through here at some point, where you'll typically have better offensive outcomes for those teams. And then you'll see the teams whose offenses kind of struggled more, well, here they are in that bottom left corner. So that covers that. One of the other things that I wanted to do here is, in terms of the models, really only looking at accuracy score, where I think it would be better if we change this to the cross-validation models here, so giving a better idea in terms of the outcome, or we could do, what was it, like not a correlation matrix, or is it? I had like a cross-validation. Classification. That's the words I was looking for. Okay. So in terms of the classification, I don't think I have that here in sklearn at the beginning. So, oh, I do. Okay, great. So I already have it. When I come down to here, what I should do then is I want to print the classification. Report, and what I want to put into here is the Y test versus the Y predict. So this is a very basic model, but this is actually going to go off of the SEM, whereas this should go here on this model. The reason why I'm saying is doing SEM is because that's the last model that was run, and so that's why it's going to pull in the Y test and Y predict from that version down here. See how I use the same Y test and Y predict. But since I copied that from up above, put that classification here. Yeah, over here, I believe. So let's actually talk about this. Remember, one is predicting rush versus pass. You can see the precision and recall are inverses of one another. Our F1 score here is about 70%. So once you weight those out with one another, basically it's better at predicting the rush correctly versus predicting pass in the cases. So where it predicted pass, it was right 68% of the time. When it predicted rush, it was correct that 74% of the time. And then because they are roughly about average in terms of the data set, you get that closer to 71% score here. So I guess it's a better idea. It's better at predicting rush correctly than it is actually predicting pass. And we would see that, I imagine, across all the versions of the model here. I want to predict. Save it. So now this version, in the 74%, we should see different outcomes, if only slightly. But it gives us a better idea on how the model is predicting one case versus another. So you can see here, it's actually much closer with more information to correctly predicting the outcome that we want. So precision and recall are very near to one another. So when it predicts pass, it's higher precision and recall than when it actually predicts, when it predicts rush, higher precision and recall versus when it predicts the pass. So those are kind of easy ways to get a better idea of what's happening here in the model. Now, if we wanted to kind of break these down, we would go into, they're roughly the same. So it's probably better overall in terms of the model to find more fields that are more predictive of the outcome that we want. Right now, we have, was it about 10 or so actual fields? 2, 4, 6, 8, 9 fields on the score differential 10 to get an idea of what the information is that's actually contributing here. If we wanted to, we could do kind of a principal components analysis to get an idea of which fields are doing it. Because it's logistic regression, we can actually look at the coefficients to getting that information and get a better idea on how to improve those numbers. So coming back to here, we kind of quickly covered the key pieces that I wanted to get through today. We got the updated graphic here with a better layout for each of the teams to get it. One of the things that I could do here is I want to add I want to add mean lines for the average rush and pass attempts, which then that would help us to break that down in the model. So come back to here. I'm pretty sure I put somewhere here. I want to say something like let me see if I can look it up. So what do we got? We got pyplot. Add a horizontal line. Set a x line. And then we want, what was that number from before? All the way up here, the average rush attempt was 4.5, and the average pass attempt was 10.9. So if I come down back to here, in this case, there should be 10.9. Color equals black. And the line style should be, let's just make it a dashed line through. And then AXB line, x equals, so this is 4.5. Black lines, line style should be dashed. Now if I add those in, give me a moment. like I said, if you have any questions on what we're doing or why we're doing it, please feel free to drop them in the chat, or you just want to know something more general, whether it's about data science or machine learning, or how the NFL data is being used, please feel free to ask them. So what we're doing right now is we're updating our graphic. So here you go. Got a line running through, just give you an idea of kind of how the quadrants will break down. So if I wanted to tighten this graphic up, I can make it from, let's say, 8 to 14, and then 3 to 6. So 8 to 14, and then 3 to 6. So that's 3 units, 6 units. So the ratio should stay roughly the same for these. Black, but maybe. So I ended up with blue. Wasn't quite what I wanted. I wanted it to be a black line. Blue stands out, looks nice as well. So not the worst outcome, but tighten this up a little bit. And so we'll have a better idea on the graphic in terms of where those quadrants actually fall for like a good offense versus a better offense or high output offense. So we'll take a moment. Okay. I'll figure out the color thing later. Why are we so slow? So the key thing is if you're trying to follow along and run this locally, you will need the folder with all the team logos here. So the version that the team that I'm missing here is the Washington Commanders logo. So that's why I have it just displaying as text for now. For whatever reason, the kernel's dying. There we go. Really stop so we can run it. We'll just go back to using that blue line for now. We made improvements to the model output. So we're getting the classification report, which helps us to determine how well we were doing. You can see for that very basic model on the logistic regression, there was quite a bit of variance between correctly predicting run versus pass. But then as we added more information, you can see now instead of there being a almost 6-point difference between the two groups, it's now down to like a 2-point difference, which is very small in terms of grand scheme of things. And if we were trying to improve the model, it would be better served by us finding a few more variables to throw in here and hopefully be more predictive overall. So here we go. Now that I cut out some of the white space in the graphic, you can kind of see here, a lot of the offenses are actually grouped into this corner where you have kind of the more productive offenses. You can see you really don't want to be in this group here where you're kind of about average at passing, really below average. So you don't want to be kind of these 4 teams in terms of Tampa, the Rams, the Colts, and the Steelers, where you have way below average rushing in the case of Tampa Bay and still below average passing. Same thing for the Rams here. And in the Steelers case, you have slightly below average rushing, but way below average in terms of the pass. So we covered all the key points for today's session. So we've updated this graphic to actually include the team logos. You could, if you're doing this on their own, move these lines a little bit if you wanted. For right now, I just have them as the average outcomes on a given play. But if you wanted to, let's say, put another line here, let's say 1 standard deviation above the average, so you have an idea of like who those truly elite offenses are, and in which case you can kind of see the grouping here, even in the graphic now, where they're just better in both sides of the offense in terms of you got Atlanta, Buffalo, Detroit, and Chicago here. You want to talk about like above average in terms of passing. You got the line going across here. And so you would say you've got Miami, Denver, Philly, San Fran, Atlanta, and Buffalo. Chicago's probably right about on that line as well. And then in terms of the rushing, let's just use this extra half yard. You see there's a large amount of teams that are now grouped into that side. So next time what we'll do is we'll work on, instead of just doing rush versus pass, see if we can start to predict some of the routes information. We have the receiver alignment, who the teams are, but then could we actually predict based on, what I'm hoping is that this will use the player data, what are the teams, what are the routes that are likely to be run on a given team for an offense. So we know the formation. Let's say there are 3 receivers on the field. What routes would they be likely to run when we know like it's a pass play, right? So we're only looking at the pass plays. What routes do they run? And then can we tell who those are? Because we're able to predict with about 70% confidence run versus pass. Well, can we also predict what the offense is going to do with those combinations so we have a better idea? Or is it, do we need to add more data to our model, which is likely going to be the case? So the next session for this will be on Friday. So go through, I'll look through the data field again, where just trying to get an idea of what's in the data sets that we can find and hopefully be useful. Again, remember that we can only use information that we know before the ball is snapped to try and predict it. So even though the route combination would be an outcome after the snap, we can only use information that we know before the snap. So we know already, like in our models that we've been using, the offensive formation, because you can see that before it's snapped, what is the situation of the game. And then we'll add that player information and see if there's anything else in the data that we can add to it to try and get it. And then if that's useful in the route combinations, that may also then be useful to come back to this very basic predicting run versus pass situation and see if we can get better. Ideally, you'd want to get up into, I would say, that 80-85% range. So looking at what we can, or what we know, again, we can only use the stuff that's before the snap. So I'd have to look more closely at that data set or the data field list and see if there's more information that we can tie in, and then work on incorporating that into our data set. So for those of you who are watching, thank you for coming. If you are seeing this after the fact, please feel free to comment on anything you found interesting, or if there's something in particular you would like to learn about so we can add it while we cover everything here on the Big Data Bowl. We've got about a month to go in terms of getting a presentation put together. So that's why we're going to be moving into the more advanced models over the next week or so, because we want to put together some type of output, but just predicting run versus pass isn't going to say much of anything yet. We want to get to a phase where we are being able to, let's say we know it's going to be a pass play. Here are the expected route combinations that a team's going to run and how you should adjust your defense based on that information. So that's all for now, and I'll see you guys on Friday as far as the Big Data Bowl is concerned, and then I will be live tomorrow as well, updating our reinforcement learning project on teaching AI how to play Pokemon Red. We've had a lot of good progress there, so it'll be a fun session for tomorrow. So thank you, and have a good night or good afternoon.